Hey guys, today in Pre Algebra we're talking about words and expressions. This is chapter 1 and section 1. First thing we're going to talk about is translating verbal phrases into expressions. So to find the number of cups of ice for 9 friends, Lisa and Patty can use the numerical expression 9 times 3. Numerical expressions contain a combination of numbers and operations such as addition, subtraction, multiplication, and division. Here in the first example, we're asked to write a numerical expression for each verbal phrase. So if I were to say to you, the total amount of money, you have $9 and $12. Well, we know right now that the word total really relates to the sum, or how many of each, added together. The phrase then, we say the sum of 9 and 12. And to write that as an expression, a numerical expression, you would write 9 plus 12. Here in B, it says the age difference between 15 years old and 10 years old. Your key word here is difference, and we know that difference is relating to subtraction. So the phrase really is said the difference of 15 and 10, and you would write that 15 minus 10. Okay? We're going to skip the guided practice for now. If you really want to take a look at those, you can do them and come check with me for answers. The second thing we're going to talk about today is order of operations. Many of you have heard this term before, but it says to evaluate an expression, you find its numerical value. If a numerical expression has more than one operation, use the order of operations. So let's say, for instance, if you have addition and multiplication in the same expression. The order of operations are the rules to follow when evaluating an expression with more than one operation. Many of you in here have heard of PEMDAS. Okay, and if you'll notice over here at the left, we have 3 steps, 1, 2, and 3. Now, there is one that they're missing in here that I'd like you to add in. So if you're going to go ahead and make a list and copy down these notes, please make sure that you're adding the E for exponents, and I'll get to that in a second. So it says step 1 over here is to evaluate the expressions inside of the grouping symbols. Well, grouping symbols really means the P. So remember in PEMDAS, P means parentheses. I'm just going to abbreviate for the sake of time. E really means exponents. M and the D really mean to multiply or divide. And the A and the S really mean addition and or subtraction. Okay? So here that step 1, the grouping symbols really are your parentheses, and those can include the parentheses, the square brackets, or even the squiggly line brackets. So you really need to keep an eye out for all of those. The second thing that they don't have in here that we're actually going to squeeze between steps 1 and 2 is your exponents. So after you evaluated it and solved everything with grouping symbols around it, you're going to want to go ahead and move on to exponents as well. Okay, after that, get rid of any exponents, and then you move on to the next step, which they call step 2. So it says multiply and or divide in order from left to right. It doesn't matter which one comes first, multiplication or division. Just make sure the key thing here is to go from left to right, just as you would if you were reading a book. Okay? And then the last step here is to add or subtract in order from left to right. Same thing again. Doesn't matter which one comes first. If subtraction comes first, that's fine. Just make sure you're reading it from left to right. All right, so let's solve a few problems here. I'm going to go ahead and write PEMDAS up at the top so we can remember our order of operations. And I'm going to rewrite all of my problems. I think it's really important for you to write everything down so you're not forgetting pieces here and there. Okay? Well, I take a look. Do I have any P's, parentheses, or grouping symbols? No, I don't. I move on to the E, exponents. I have no exponents. I move on to the M and the D, the multiplication and division. Remember, it's not multiplication first. It's multiplication and or division from left to right. Well, I can see right here I have a multiplication problem, so I rewrite my entire problem, and I know that 3 times 5 is 15. Clearly, I only have 1 step left, which then would be moved on to the addition or subtraction. 20 minus 15 is 5, okay, and that would be your answer for A. Moving on to B, 30 divided by 5 times 3, okay. Taking a look here, I have, again, no grouping symbols. I have no exponents that I need to solve for, but I do have multiplication and division, and because I'm going from left to right, I have to solve 30 divided by 5 first. 30 divided by 5 in here is 6. And I want to go ahead and make sure you're continuing out the rest of the expression. Rewrite everything else so you're not forgetting any pieces. 6 times 3 is 18, and 18 would be your answer for B. Coming over here to C, I'm going to write that all the way over here in black. So I have 4 times the difference of 10 minus 7 plus 2 times 3. Taking a look here, we're getting a little more complex, so I want to make sure that I start with my P. Do I have any grouping symbols? Well, of course I do right here. Okay, so I'm going to go ahead and solve that first. Again, rewrite everything so you are not forgetting any pieces. Okay, if you do that, you will notice that you're going to skip and forget certain things. Okay, looking over here now. Now I do have parentheses left right here by my 3. That does not mean grouping symbol. Okay, when you have a single numerical number isolated right next to another number, that really indicates multiplication. So make sure that you're being aware of when the grouping symbols have an expression inside and when the grouping symbols are really standing for multiplication. So I'm going to go ahead from left to right and solve this one first. 4 times 3 is 12. I'm going to continue the rest of my expression out there. I have addition and multiplication. I know multiplication has to come first. So I get 12 plus 6, because 2 times 3 is 6. And now here, 12 plus 6 gives me 18. And that's my answer. All right, let's take a look at D. I'm going to go ahead and extend the page here. We've got 5. Make sure you are, again, writing down everything in the exact order. 5 times 11 minus 7 plus 5 divided by 4 with another big grouping symbol around it. Okay. Take a look. Do I have a P? Do I have any grouping symbols? Well, yes, I do. I have actually 2 sets of them, and you always want to start with the innermost one first. So I'm going to go ahead and start by solving that first. So I say 5 times 11 minus 7 plus 5 is 12, and divided by 4 with my bracket symbols around it again. Now I take a look, and I have to finish solving everything inside of my bracket still. Well, I have subtraction and division, so I know that I have to do my division first. So I get 5 times 11 minus 12 divided by 4 is 3. And I finish up the grouping symbol. And it's going to be much, much easier, you're going to notice, if you continue to write everything down to the next step. That way you're not forgetting anything. Again, here I have a multiplication right here with this grouping symbol, okay? But I have to solve everything inside of there first. So I have 5 with the grouping symbol, 11 minus 3 is 8. And now I'm really left with 5 times 8, which is 40, okay? I'm going to extend the page one more time, taking a look at problem E. I have 60 minus 15 all over 2 plus 7. Now this right here is actually a division bar, but we call that a fraction bar. So you have one of 2 choices. You can look at it like solving everything on top, following the order of operations, or you can solve everything on the bottom, following the order of operations.
Please come to
if
the
I were
high
to
school
do that,
office.
I can take a look and say that, okay, 60 minus 15 is 45, and I know that 2 plus 7 is 9. Again, all I'm doing is I'm following the order of operations on top of the fraction bar, everything on top of the fraction bar, as well as everything on bottom, and they're only one-step equations, so it's really not that hard to solve. 45 divided by 9 is going to give me 5, okay? You could also look at this like 60 minus 15 divided by 2 plus 7, okay? But just make sure that you then are isolating each of those expressions in parentheses. You're going to get the same answer regardless. All right, taking a look at the last slide here, we always solve real-world examples, and those real-world examples often include basically word problems is what they mean by that. So let's take a look at what we have. It says a cell phone company charges $20 per month. Okay, so that's probably going to be a key important piece. Every month you are paying a fixed cost of $20. And you're also paying 15 cents for each call made or received. It says write an evaluated expression. Also, when you're dealing with word problems, make sure you carefully read them. We have to do 2 things in this problem, write and evaluate an expression to find the cost for 40 calls. Okay, that's going to be really important. Then make a table. So really we now understand that we have 3 things that we have to do. It says showing the cost for 40, 50, 60, and 70 calls. So the first thing we need to do is understand the problem. It says you know how much the company charges per month, okay, which was the $20. you need to find how much it will cost for 40, 50, 60, and 70 calls. Our plan is to write an expression to find each cost and organize those results in a table. So first, how are we going to solve this? We need to find an expression for 40 calls. Well, how are we going to do that? Okay, we knew, like I said before, that the fixed cost is $20 per month, and you have to pay $15 for each call made or received. We said that we made 40 calls to start, so 20, which was my fixed cost, and that has to be added to how much am I going to pay monthly? Well, 15 cents per call, and here we've got 40 calls. Okay, so expression looks like this: 20 plus 15 times 40. And here, if I follow the order of operations, all they're doing is taking 15 hundredths and multiplying that by 40, which is really giving them 6 over here. The 20 stays the same because that's my fixed cost. And here they get 26 because 20 plus 6 is 26. Okay? So 40 calls will cost $26. We need to make that table now showing the cost of 40, 50, 60, and 70 calls. If I do that, can't I just use this expression right here? 20 plus 0.15, excuse me, times x, times whatever number I need to plug in. So here, they're just plugging in the number of calls for x there. Okay? And then if you compute that out, you get your cost for each amount of calls. To check, you can just say you can look for a pattern in the cost because you know that all of the increments for calls are going up by 10. You know that the cost every time from here to here, here to here, and here to here is going to increase by $1.50. Okay? Let me know if you have any questions in class, and bring your notes to class.